Dear students, Namaskar. I hope that you all must be in sound health and must be continuing your studies with great zeal and enthusiasm. Children, today we are going to discuss Chapter 8 of Class 9 Science, Motion. Before we start with our chapter, let us recall what you already know. What is motion? What is uniform motion? Give a few examples of objects which are in motion from your everyday life. Now let us see what we shall discuss today. Motion along a straight line, measuring the rate of motion, speed with direction, rate of change of velocity, uniform circular motion. Children, do you know what is motion? Let us try to understand about motion. The importance of motion in our everyday life may be realized by looking at these images. The line associated with life, which is in continuous motion, indicates that the person is living. When this lifeline stops, it indicates death. The flow of blood through our veins and arteries show that we are living. In everyday life, we see some objects at rest and others in motion. Even the air around us is in motion. However, we are not able to see air moving. Motion of air can be inferred by observing the movement of dust particles, branches, and leaves of trees. Even the smallest particle called atom is also in motion. Atoms, molecules, planets, stars and galaxies are all in motion. Children, have you ever thought what causes the phenomena of sunrise, sunset and changing of seasons? It is due to movement of the earth. But we don't directly perceive the motion of earth. This is because we are also moving along with earth. So children, we can perceive the motion of an object if we observe the object from a distance in stationary state. We can see the motion of earth easily from a satellite or another planet. For the passengers in a moving bus, a passenger inside the bus sees his fellow passengers to be at rest. However, a person standing on the roadside perceives the bus along with passengers as moving. So children, in this chapter we are going to discuss all types of motion, and we shall also learn to express such motions through simple equations and graphs. Motion along a straight line. Let us try to understand this with the help of an example. Let us imagine that 4 friends A, B, C and D are sitting along 4 sides of a table. Spread a white sheet on the table and make sure that the sheet does not have any marking on it. Now place an ant on the table and describe its motion. According to A, the ant is going towards right. According to B, the ant is going towards left. According to C, the ant is moving towards him. And D says that the ant is moving away from him. After all this discussion, to know about the motion of ant, mark a point in the center of the table and draw 2 mutually perpendicular intersecting lines through this point. Now mark north, south, east and west directions on the lines. Now we will be able to see the motion of the ant and describe it easily. Now if any person explains about the direction of motion of the ant, it will be easily perceived by all children. We now know from this example that to describe the motion of an object, we need to specify a reference point. Now we will discuss about motion along a straight line. We shall describe this motion by an example. Consider the motion of a car moving along a straight path. The car starts its journey from O, which is treated as its reference point. Let A, B and C represent the position of the object at different instants. At first, the object moves through C and B and reaches A. Then it moves back along the same path, reaches C through B. The total path length covered by the object is OA plus AC, that is 60 km plus 35 km, which is equal to 95 km. This is the distance covered by the object. To describe distance, we need to specify only the numerical value and not the direction of motion. Students, if we observe the initial position of the car at O and its final position at C, after completing the motion, the distance is 25 kilometers. This is called the displacement of the object. This means the shortest distance measured from the initial to the final position of an object and is known as the displacement. To describe displacement, we need to specify the numerical value of the motion as well as its direction. For example, as we saw in this case, the distance covered by the car is equal to 95 km, whereas the displacement of the car is 25 kilometers. Thus, the magnitude of displacement is not equal to the distance or path length covered by the car. If we consider the car to travel back to O, the final position coincides with the initial position, and therefore the displacement is 0. However, the distance covered in this journey will be 120 km. Now if we consider that the car travels from O to A, and for this motion from O to A, the distance covered and the magnitude of displacement is 60 km. So children, we can say that displacement can be smaller or equal to the distance covered, but displacement can never be more than the distance covered. Now let us try to understand the difference between distance and displacement. Distance. It is the total length of the path covered by an object, whereas displacement is the shortest distance measured from the initial to the final position of an object. Distance is the physical quantity only specifies magnitude of motion, whereas displacement is the physical quantity which specifies magnitude as well as direction. Distance can be equal or more than displacement, whereas displacement can be equal or smaller than distance. The distance covered by an object can never be 0, whereas the value of displacement can be 0. Distance can never have a negative value. Displacement can have a negative value, whereas negative sign indicates the opposite direction of motion. Uniform motion and non-uniform motion. Children, when an object covers equal distance in equal intervals of time, it is said to be in uniform motion, whereas when an object covers unequal distance in equal intervals of time, it is said to be in non-uniform motion. Let us understand this with the help of an example. Consider a car which covers 16-meter distance in 8 seconds. It starts from its initial position O and covers 4-meter distance in 2 seconds. In the next 2 seconds, it covers another 4 meter and the distance becomes 8 meter. In next 2 seconds, it again covers 4 meter of distance. In next 2 seconds, it covers another 4 meter of distance and the total distance covered by the car comes out to be 16 meter and the total time taken to cover this distance is 8 seconds. So this car covers the total distance of 16 km from point O to D. You are observing here that the car covered 16 meter of distance in 8 seconds and covered 4 meter distance in every 2 seconds. This means that distance covered is directly proportional to time taken. Such a motion in which equal distance is covered in equal intervals of time, it is called a uniform motion. Now let us take another example. In this, a car covers 16-meter distance in 8 seconds, starting from point O. As the car starts, it covers 2-meter distance in first 2 seconds. In the next 2 seconds, the car covers 6 meter of distance. In the next 2 seconds, the car travels 3 meter and in the next 2 seconds, the car covers 5 meter of distance. Car covered a total of 16 meter of distance in 8 seconds, but the car covered unequal distances in equal intervals of time. Such a motion is called non-uniform motion. Measuring the rate of motion, speed. The distance covered by an object per unit time is called speed. The SI unit of speed is meter per second. Centimeter per second and kilometer per hour are other units of speed. Average speed is equal to total distance travelled divided by total time taken. That is, V is equal to S divided by T. Speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate average speed. In case of velocity of the object is changing at a uniform rate, then average velocity is given by the arithmetic mean of the initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Mathematically, V average is equal to U plus V divided by 2, where V av is the average velocity, U is the initial velocity and V is the final velocity of the object. Speed and velocity have the same units, that is meter per second. Rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of an object for any time interval is 0. However, in non-uniform motion, velocity varies with time. It has different values at different instants and at different points of the path. Thus, the change in velocity of the object during any time interval is not zero. Can we now express the change in velocity of an object? We introduce another physical quantity called acceleration, which is a measure of the change in the velocity of an object per unit time. That is, acceleration is equal to change in velocity divided by time taken. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is equal to v minus u divided by t. This kind of motion is known as accelerated motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. The SI unit of acceleration is meter per second square. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. The motion of a freely falling body is an example of uniformly accelerated motion. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. For example, if a car traveling along a straight road increases its speed by unequal amounts in equal intervals of time, then the car is said to be moving with non-uniform acceleration. Uniform circular motion. Children, in this chapter we have discussed the simplest form of motion called the rectilinear motion, that is, motion of an object in straight line. Now we shall discuss about uniform circular motion. As the name suggests, circular motion means when the object moves in a circular path. Uniform means the speed of the object during the entire circular motion will be same. Such a motion is called uniform circular motion. For example, revolution of Earth around the Sun. The change in the velocity could be due to change in its magnitude or the direction of the motion or both. When the velocity of an object changes, we say that the object is accelerating. Let us consider an example of the motion of an athlete along a rectangular track ABCD. Let us assume that the athlete runs at a uniform speed. In order to keep himself on track, he quickly changes his speed at the corners. It is clear that to move in a rectangular track once, he has to change his direction of motion 4 times. Now suppose instead of a rectangular track, the athlete is running along a hexagonal shaped path ABCDEF. In this situation, the athlete will have to change his direction 6 times while he completes one round. It is observed that as the number of sides of the track increases, the athlete has to take turns more and more often. If we go on increasing the number of sides indefinitely, you will notice that the shape of the track approaches the shape of a circle and the length of each of the sides will decrease to a point. If the athlete moves with a velocity of constant magnitude along a circular path, the only change in his velocity is due to the change in the direction of motion. The motion of the athlete moving along a circular path is therefore an example of an accelerated motion. We know that the circumference of a circle of radius r is given by 2 pi r. If the athlete takes t seconds to go once around the circular path of radius r, the speed v is given by v is equal to 2 pi r divided by t. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. There are many more familiar examples of objects moving under uniform circular motion, such as the motion of the moon and the earth, a satellite in a circular orbit around the earth, a cyclist on a circular track at constant speed, and so on. Children, you all must have moved a stone tied to a thread, and when you release it, suddenly it moves in a straight path. When an athlete throws a hammer or a discus, once released in the desired direction, the hammer or discus moves in the direction in which it was moving at the time it was released. On being released, the stone moves along a straight line tangential to the circular path. This is because once the stone is released, it continues to move along the direction it has been moving at that instant. This shows that the direction of motion changed at every point when the stone was moving along the circular path. Recapitulation. The uniform or non-uniform motion of an object depends on the velocity of the object, whether it is constant or changing. The distance covered by an object per unit time is called speed of the object. The three equations of motion are v is equal to u plus at, s is equal to ut plus half at square, 2as is equal to v square minus u square. Children, now I shall ask you a few questions and I hope that you all might be knowing the answers. My first question is, if acceleration is opposite to the direction of velocity, then the acceleration is, and the right answer is negative. My next question, distance time graph can be used to calculate dash of the object. So what do we calculate from a distance time graph? The answer is speed. My next question is, the area enclosed by velocity time graph and the time axis will be equal to the magnitude of dash of the object. And the right answer is displacement. My next question, what is the formula for average velocity? And the formula for average velocity is v is equal to u plus v divided by 2, where u is the initial velocity and v is the final velocity. My next question, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find first acceleration, second the distance travelled by the train for attaining this velocity. And the solution to this question is, u is given as 0 meter per second, v is given as 72 km per hour, which needs to be converted into meter per second. So, by solving 72 km per hour, we get 20 meter per second. Time is equal to 5 minutes, which is equal to 300 seconds. Now, to find out the acceleration, we are going to use our first equation of motion, and according to first equation of motion, a is equal to v minus u divided by t. By substituting the given values, we get acceleration to be 1 by 15 meter per second square. Now we shall find out the distance covered by the train. For this, we are going to use the third equation of motion, 2as is equal to v square minus u square. So 2as is equal to v square minus 0 square, as initial velocity is 0. By substituting the respective values, we get the value as 3000 meters, that is 3 kilometers. So, after solving this problem, acceleration comes out to be 1 by 15 meter per second square and distance covered by train is 3 kilometer. Children, with this we complete our chapter, and I hope that you all must have listened to the chapter carefully and understood it well. Children, stay home, stay safe, keep learning and keep growing. Thank you.